We're going to be looking at the following circuit diagram. We need to rewrite the Fourier series for the following waveform using the alternative trigonometric form given below. So using this form, we've found this right here. Okay, and the alternative form is asking us for a few specific things down here. And looking at this alternative form, we know that our A of n is right here. And since our A of n is right here, what we're going to do is try to find it. Now, this A of n is not necessarily this A of n. To correctly find our A of n, we are going to set the uppercase A subscript n equal to the square root of our A squared plus our B squared. And this is A n squared and B n squared, which is what this is right here. And so our A n squared is going to be this and this right here. So that is all of A n squared. And then our B n squared is going to be this next part where we have this and this. The reason why we don't include the sign is because it has a t in it. So now we can rewrite this. We are going to say that our A subscript n is equal to the square root. Our A n squared is just going to be the 80, or let's just write all of this out, right? So we're going to have a minus 80. We're going to have sine of pi n over 2. And this is all over pi n. And then this is all going to be squared. So we should actually make this square root a little bit bigger. So I'm going to rewrite it like this. And now we can deal with our bn. So we're going to do a plus. Inside of here, we're going to have the 240 over pi times n squared. So this is what we have, and what we can do is take out the pi n at the bottom after we square it. And this is going to give us a 1 over pi n. And that's how we would get this right here. So that so far checks out. We're then going to have the square root. Inside of here, we're going to have our 80 squared times, well actually technically since it's all in the same square root, we have to square everything. We're going to have our 80, this is minus 80, times the sine. We're going to have pi n over 2. This is all squared, plus 240 squared. So this is what we have. And what we can do with this is plug it into a calculator. I'm going to use the Symbol Lab calculator. And so it's going to look like this. So we have our 240. We need to be specific what we plug in. It's asking us for N159. So I put a 3 in here, but I'm going to replace it with a 1. I'm going to click go. And in clicking go, we get 253 if we have 1 in here. So the answer for this first part is 253. Now let's try if we were to have the 3 in here, because the next one is asking us for n of 3, 5, or 3, 7, and 11, when the first one was asking us 1, 5, and 9. And this gives us the same thing. So we're going to again have 253 over n pi. Now we need to find the angle. And the angle is going to be that our theta is equal to tangent -1, where we have our b of n over our a of n. So now we can rewrite this. We're going to have tangent -1 inside of here. We are going to have our b of n. We know our b of n is the 240 over pi n. And since we have a pi n underneath both of these, what we can do is cancel them out. And we will be able to actually see that in a second. So let's just write it all out. So we have 240 over pi times n. And then we have a minus 80 times sine pi n over 2 divided by pi n. And so what we're going to do here is we can multiply the numerator and denominator by the same thing. So we're going to multiply it by the inverse of this, and that is going to cancel out the pi n's. So we can draw arrows for our steps, and then this is going to leave us with the tangent -1. We're going to have 240 divided by a -80 times sine pi n over 2. And so this is going to be our equation, right, for a tangent -1. And then we can start plugging some things into here. Now I'm not going to do it in Symbol Lab because it has to be in degrees, and I think Symbol Lab does it in radians. It's easy to convert, but it's easier just to do it on a calculator. So first we want to plug in a 1 because we need to solve for the first part. So we're going to have tangent -1, 240 divided by parenthesis -80, and then, well, we can just look at the sign, right? And so for 1, if we plug a 1 into here, n is equal to 1, the sign is going to be pi over 2. Pi over 2 is just going to give us 1 when we're looking at the sign of it. So we're really just having 240 divided by -80, or tangent -1 of -3. And this is going to give us -72. Now, we need to go clockwise from the origin. So if we draw out a graph here, we're going to have 0 degrees, we have a -90 degrees, and then we have a -180 degrees. And so if we're going -72, right, what we're going to do is not actually subtract. We're just going to take this and go this way. So we have a -72 going like this. And this is going to leave us right here. Well, on our graph, where is this? We're going to have our -180 degrees, and then we're going to have a -72 degrees. And so this is basically turning it into an addition. And then from here, we're going to get approximately -108 degrees. So the answer here is -108. Now, we have this angle right here, an angle for the next one, and it is when our n is equal to 3. So when our n is equal to 3, we know that we're going to be over here, which is really, it's 270 or -90, whichever, and this is going to give us a -1. So we're basically going to have tangent -1, and then we have 240 over 80, but remember, these will cancel out, this will simplify, so it's going to be basically a -3. But since this, if we plug in a 3, is going to give us a -1, the negatives cancel out, we're just left with a 3 inside of here. We're going to basically have a 72. Now, this 72 is not going this way, because that is counterclockwise. When we go clockwise, same direction as a clock, we're going to go this way. And this way, the angle here, since we can't go this way, we're just going this way. We're just going to subtract 72. And so for here, we're going to have a -72 degrees. And that is how we would look at this specific problem.